Begin. So, good evening, everyone, and this is lecture number 1, and we are dealing with motion in 2 dimension. Now, in the previous classes, we had dealt with motion in 1D. We had seen motion in a straight line. But at the same time, if you remember, we had also seen motion in 2 dimension. Yes or no? Did we see motion in 2 dimension? Or did we not see motion in 2 dimension? What do you think? Did we do questions of motion in 2 dimension? Yes or no?
Yes, sir, we did.
We did, right? So, without telling you anything, let me give a question straight away. And let us start with this question. The position vector of a particle is given by 2I minus. Okay, let me make it like this. Okay, so the position vector of a particle is given by 2t square I minus 3tj. So the position is given in terms of I and j. Is this motion in 1D or is it motion in 2D? Tell me.
2D, sir.
2D. Find velocity and acceleration of a particle as a function of time. Can you do that for me? Find the velocity and acceleration of the particle as a function of time. I'll give you 2 minutes to do this. This is how we start motion in 2D. 2 minutes. Okay, so I have the answer straight away, and the velocity is the derivative of this thing. So I will just differentiate this 4ti minus 3j. Right? 4ti minus 3, there is the acceleration velocity. I differentiate it once more. 4I is my acceleration. I have found out both the velocities and acceleration. Do we understand this? Yes or no? Everyone understands this? We understand this? Yes or no? I'm waiting for your answers. We understand this. Now, can you tell me what type of motion is this? Is this motion with uniform acceleration or is this motion with non-uniform acceleration? I again repeat my wordings, same wordings. Is it motion with uniform acceleration or is it motion with non-uniform acceleration? Yes, bacha. This is a motion with uniform acceleration. Yes or no? Do we understand this? Well, this is simple motion in 2 dimension. Now I could have done this problem in a slightly different way. How I could have done this? I could have taken this I. This I is basically the x component, and this j is basically the y component. I could have, instead of doing the question straight away, I could have done this question in a different way. And how could I have done this in a different way? I could have written here one equation along x-axis and one equation along y-axis. Do we understand this? Again, if I write equation along x and y-axis, I have to choose a sign convention. Everything going this side is positive, so everything going on the other side is negative. Everything going up is positive, so everything going down is negative. Do we understand this? Yes or no? Do we understand this? Raise hands will give me more confidence that we understand this. Okay, so now I could have written the x coordinate of the particle as 2t square and the y coordinate of the particle as minus 3t. Do we understand this? Yes or no? I could have written x coordinate as 2t square and y coordinate as minus 3t. Now, if I differentiate this x with respect to time, I will get velocity ka x component. And velocity ka x component would be 4t. Similarly, velocity ka y component would be minus 3. Do we understand this? If I combine these two yellow things, these two pink things, by combining these two pink things, I will get the velocity like this. Do we understand this? 4t I minus 3j. Am I clear? Can I have raised hands from everyone that we understand this? Yes, no. Okay. Now I can differentiate it again. If I differentiate velocity along x, I will get acceleration ka x component. That will be 4. Acceleration ka y component, that is equal to 0, as you can see. Now if I look at the green thing, I can combine both this green thing and I will end up with here the acceleration ka vector quantity. Yes or no? No, yes. So I've done the same question, but I have done this by breaking it up into x and y and using the sign convention. Do we understand this? So basically, there are two ways of doing any question in 2D motion. Either you can write it in the vector form I, j, k will not be there probably, I and j, and then you can differentiate it from position, you will get velocity, from velocity you will get acceleration. Either you can do it that way, or you can break it up into x and y components and then you can do it. Do we understand this? Yes or no? No, yes. Anyone understands this? Raise hand will give me more confidence that I'm on the same page, right? So now what I can do is I can write the equations of motion and remember most of the question that we are going to get would be for uniform acceleration. in 2D. Now, how will I write equation of motion for uniform acceleration on 2D? I will try to break them. The equation is already there. We already know this. But what I can do is now I can try to break them into x and y component, and then I can write the equations. Do we understand this? What I'm trying to do here? So basically, I am going to write the equations, and then we can combine it and we can write the vector equation. For example, one set of equation can be written along x-axis, the other set of equation can be written along y-axis. For example, if the first equation of motion can be written as x is equal to ux into t plus half ax into t square. Do we understand this? Or let me not write this equation. Let me write it in the same sequence that we wrote it in the first. The first equation that we wrote was v is equal to u plus at. Do we remember this? Now, instead of just writing it as v and u, I can write it as vx, vx, ux, and ax. Do we understand this? Raise hands will give me more confidence that we understand this. I can write the position x as ux into t plus half ax into t square. The third equation can be written as vx square is equal to ux square plus 2 times ax multiplied by x. I hope you all understand this. Fourth equation, I can write it as v x ka average will be equal to vx plus ux divided by 2. The fifth equation, I can write it as displacement x will be equal to vx plus ux divided by 2 multiplied by t. Are you getting me, or is it getting too complicated for you to understand? Please raise your hands and let me know. The sixth equation, I can write displacement in the nth second will be ux plus ax by 2 into 2n minus 1. Do we understand these equations? Yes or no? No or yes? Do we understand these equations, my dear friends? Do we remember these equations? Yes or no? No or yes? Anyone having any doubt? Please raise. Anyone having any doubt? Please raise. Now, this is the equation that I have written for the x-axis. Can you now write the equation for y-axis on your own? Raise hands will give me more confidence. Should you write the equation of y-axis on your own? I'll give you 2 minutes. Can you do this? I'll give you 2 minutes to do it. 2 minutes. Yes, bacha. Have you written the equations? Everyone? Yes or no? No, yes. Okay. Can anyone tell me what is the first equation? Fatafat. Unmute yourself and let me know. Yes, please tell me, Fatafat. Vy is equal to uy plus ayt. Y is equal to uyt plus half ayt square. Vy square is uy square plus 2 times ay multiplied by y with proper sign convention. Vy ka average is final velocity along y plus initial velocity along y divided by 2. Position y will be Vy plus Uy divided by 2 multiplied by 3 multiplied by t. Displacement in the nth second will be Uy plus Ay by 2 and minus 1. Everyone got it correctly? Well, then congratulations. This is what it is. This is the equation of motion. Now, anyone has written this? Anyone understands this? Is there anything new about it? I don't think there is anything new about it. What do you think, bacha? Do you think there is anything new about it? Anyone understands this? Okay. Now, as soon as we hear the term motion in 2 dimension, remember the first example that we did was also a case of motion in 2 dimension. But as soon as we hear the term motion in 2 dimension, generally, which type of motion comes to your mind when you think about motion in 2 dimension? What is the type of motion comes to your mind when you think about motion in 2 dimension? Yes, my dear friend. What is the first? The first thought that comes to your mind should be circular motion. Okay, that's new. No one told me that before. Thus, circular motion is definitely a case of motion in 2 dimension. Yes, Probably the first thought that comes to everyone's mind when they think about two-dimensional motion is this one, projectile motion. Now, as soon as I say projectile motion, what do you understand by projectile motion? We'll do it fatafat because we don't have so much time that we can spend on this. What do you mean by projectile motion? Tell me fatafat. Tell me fatafat. Projectile motion. As soon as you hear the term projectile motion, what is the thought that comes to your mind? Obviously, it is a case of motion in two dimension. What else? What type of motion is projectile motion? Have we done this projectile motion before? When I say before, I don't mean in your 11th standard and 12th standard. When I say projectile motion before, what I mean is, have we done this in the previous chapter? What we have done in the previous chapter, have we done this projectile motion in the previous chapter? Yes, have we done this projectile motion in the previous chapter? Chandrika and Anjali, you are there in the same ID. Just saw this same ID studying together. Good. Yes, have we done this projectile motion before? Fatafat, tell me. Motion of object projected in air. Have we done this before, Shruti? We have definitely done this before. Any motion that is taking place under the effect of gravity. Any motion which is taking place under the effect of gravity is known as projectile motion. Any other force is not present. Any other force is not present. All types of resistance force, any other force is neglected, is not there. So there is no air resistance. The motion is taking place under the effect of gravity. G, the acceleration due to gravity, is assumed to be constant. It's assumed to be constant and it is directed vertically downwards. And it is directed vertically downward, which is obviously not the case. It is not directed vertically downward, but this is the assumption that we are taking. Do we understand this? Yes or no? No, yes. We have done this before. We have done this before. And that motion that we have done, motion under gravity, is an example of projectile motion in one dimension. So I can write the next heading as projectile motion in 1D. And this projectile motion in 1D is nothing but motion under gravity that we had done. We have already done that. Yes or no? No, yes. We have already done that. In that case, what was happening was, I had a ball, I had a stone, I was throwing it vertically upwards. It was going vertically upwards and it was coming vertically downwards. Do we understand this? Yes or no? No, yes. That was projectile motion in one dimension. Projectile motion in one dimension. We have already done that. So if I throw the ball vertically up, it just comes vertically down. We have done that. So I'm not going to throw the ball vertically up now at 90 degrees. I'm throwing it at some angle. Do we understand this? So that is how I can have the other type of projectile motion. The first type of projectile motion that we have already done, you can call it as vertical projectile motion, or you can call it as vertical projectile. You can call this motion as vertical projectile motion. Up and down and up and down and up, vertical projectile motion. Okay, you can call it vertical projectile motion. Then we can move on to the second type of projectile motion, and I can call it as oblique projectile motion, or I can call it projectile motion in 2 dimensions. Now, in case of oblique projectile motion, what is going to happen, my dear friends? Everyone knows this. Tell me, what is going to happen in case of oblique projectile motion? Yes, my dear friend. What is going to happen in case of oblique projectile motion? Yes, tell me. In case of oblique projectile motion, what is going to happen? Instead of throwing the stone vertically upwards, my dear friends, what I am going to do is throw it at an angle like this. I am going to throw it at an angle u with initial velocity u at an angle theta. So what will happen, instead of only going up and down, it will go up and down, and it will also move. It will go up, but it will also move in the forward direction. Yes or no? No, yes. Now this velocity u can be broken up into 2 components. One is u cos theta along x-axis. So I can call it ux. One is u sine theta along y-axis. I can call it as uy. Yes or no? No, yes. It reaches the maximum height h. It has a horizontal range, which I call it as capital R. Then it spends some time in air. That time is known as time of flight. Do we understand this? Yes or no? No, yes. Now, remember, I can break this motion. I can break this motion into 2 parts, into horizontal part and into the vertical part. We all understand this? Yes or no? No, yes. I can break this motion into 2 parts. One is the horizontal part and other one is the vertical part. And that is how I can study this motion by breaking up into horizontal direction and breaking up into vertical direction. In the horizontal direction, when I break it up, there is no other force acting on it. Therefore, the acceleration along the horizontal direction is 0. Yes or no? Do we understand this? And therefore, its velocity along x, u along x is equal to v along x. Velocity along x does not change. Do we understand this? Its velocity along x does not change. Do we understand this? Yes or no? But when I talk about the y-axis, it has an acceleration along y-axis which is minus g because it is downwards. This acceleration is downwards and therefore its vertical velocity changes. At the initial point, if I talk at the initial point, the vertical velocity is u sine theta. At the highest point, the vertical velocity becomes 0. And when it comes back, it comes with the same speed, but the direction of velocity is reversed. Do we understand this? So this is just like the motion under gravity. So there is one motion which is happening under gravity. At the same time, there is one motion which is happening along the horizontal. Do we understand this? Yes or no? No or yes? I'll give you 2 minutes to note this down. I hope everyone understands this. Yes or no? No, yes. Okay. Please note it down. Okay. So you have understood this? Yes or no, everyone? Now we can write the equation along horizontal and vertical directions. And those equations you already know. So I'll just put them down again so that just you can just go through them once more. These are the equations along horizontal and vertical direction. We all know this, yes or no? From here you can find out the three things that we are supposed to know. The time of flight, the formula for time of flight t is 2u sine theta by g. Do we all know this? Yes or no? Yes or no? No, yes. I can also write it as 2 times uy by g. Now, as soon as I write it in this particular form, my dear friends, it becomes clear that this time of flight only depends on the vertical component of velocity. Do we understand this? Yes or no? No, yes. Okay. The second formula can be written as the range and the number of ways in which you can remember this formula. It will help us in solving more questions. It can be written as ux multiplied by time of flight. This is one way of writing it. It depends on ux as well as it depends on t. The second way of writing it as I put the value of t from the first equation. So I can write it as 2 times ux uy by g. That is the second way of writing it. The third way of writing it is by writing the values of ux and uy. So I can write it as 2 times u cos theta, u sin theta by g. Now I can say 2 times sin theta cos theta is sine of 2 theta. So I can write it as u square sine 2 theta by g. Do we all understand this? Yes or no? No or yes? Everyone is noting down these points. The more the number of ways in which you can remember this, the better it is going to be for you to solve questions. Every question can be solved in whatever ways you two or three formulas are there. But if you can remember, the number of ways in which you can write them, it will be better for all of us. Do we understand this? Have we noted this down? What is the other formula that is left? What is the third formula that is left? Tell me, my dear friends. Oh, here we can write one more formula for maximum range. Range is maximum. When is the range maximum? When theta is 45. Yes or no? No, yes. Raise hand will give me more confidence that I am on the same page. So maximum range will be u square by g. Yes or no? No or yes? Maximum range will be u square by g. Now, one point that you must remember for complementary angles. I hope you know this. For complementary angles, that means one angle is theta and the other angle is 90 minus theta. Range is same. Do we know this? Yes or no? Yes or no? No or yes? For complementary angles, range is same. I hope everyone is following me. What is the third formula? What is the next formula that is left? The next formula that is left is for maximum height, H max. Now, there are a number of ways in which you can write this formula. Can anyone tell me? What are the number of ways in which I can write this? I can write it as uy square by 2g. As soon as I write this formula, this must remind you of that maximum height u square by 2g. The formula is same. The only difference is in that case of motion under gravity, the entire velocity was along y-axis. So we can write instead of uy, you just write u square by 2g. Here it has two components. Here it has two components, ux and uy, and therefore in maximum height, we are writing the formula in terms of uy. Do we understand this? Yes or no? No, yes. Huh? Say fatafat. Do we understand this? Raise hands will give you more confidence. Okay, you can also write it like this. U square sine square theta by 2g. Everyone understands this? Yes or no? No, yes. Huh? Yes, well done, Shruti. Now, remember one more formula that might help you a lot in certain cases. You can divide this H max by range. H max by range. Can you tell me what is the formula that you will get? I shall give you 1 minute to do this. H max divided by range. H max divided by range. Yes or no? Will you remember this formula? It will be coming as tan theta divided by 4. Yes or no? The more the number of ways in which you can remember this, my dear friends, the better it is for all of us. Do we understand this? So these are the most used formulae that are going to come for straightforward questions. These are the formulae that you will have to apply, and with this you can get your desired answers. But you might have sometimes questions which are not straightforward. So first of all, let us solve one or two questions which are based on these formulas. I hope everyone has written these formulae. Let me just give you one or two questions so that these formulae are there with you. So this is the first question that comes. A body is projected with a speed of 30 meter per second at an angle of 30 degrees with the vertical. Find the maximum height, time of flight, and the horizontal range. Question number 1. You shall have 2 minutes to solve this. Okay, solve all the parts and then give me the answer, bacha. Okay. Have you got our answers, my dear friend? Everyone, please raise your hands and let me know that we have got your answers. Yes or no? No, yes. So, how are we supposed to do this? Solution? Just have to put the formula. The formula for maximum height is u square sine square theta by 2g. Yes or no? No, yes. You can put this values. I think you will get 135 by 4, something like this. Yes or no? No, yes. Everyone got the same answer? Time of flight is 2u sine theta by g. If I put the value of 2, 2 is 2, u is 30, sine theta is sine of 30. No, not 30. The angle is with the vertical. Remember, 30 degrees is the angle with the vertical. I have to take the angle with the horizontal. That is the main point of this question. So angle ka value is 60 degree. Do we understand this? Yes or no? No, yes. That was the only thing that you had to remember in this. If you put these values here, I will get 3 root 3. Do we understand this? Yes or no? No or yes? Do we understand this, everyone? Please raise your hands and let me know. Everyone understands this? Yes or no? Okay, that is the only thing that you had to see. Then it is very simple. The horizontal range R, you can find it out in any ways. You can use u square sine 2 theta by g, or you can find out the value of ux and then multiply it by t. Doesn't matter. Mm, no matter how you do it, you will always end up with the same answer. Everyone got this? Yes or no? Can I have raise hands from everyone that we got the answer so that I can quickly give you the second question and move ahead in life? Yes or no? No, yes. This is the next question that I'm looking at. Question number 2, and I'm expecting a quick fire answer from all of you. This is the next question. The velocity of position of a projectile is given by u is 5y plus 10j. Find the three things are there. You'll get 2 minutes to solve this one. Well done. We are getting answers from everyone. That is a good sign that everyone understands what we are up to. So, time of flight. What is the answer for time of flight, my dear friends? Time of flight is 2 seconds. Maximum height is 5 meters and the range is 10 meters. Are you getting the same answer? This is 2 seconds. Maximum height, my dear friends, is coming as 5 meters. And the range is coming as 10 meters. Are we all getting the same answer, my dear friends? Yes or no? No, yes? Well done. That means we have passed the first stage of this, and now I can probably present other type of questions. Let me see if I have it here. Okay. As you can see, the more the number of questions that we do, the better we are going to be. Let us move on to the next question. And this is the next question. Question number 3. The more the number of questions you do, the better are your chances. A particle is thrown with a velocity u at an angle alpha from the horizontal. Another particle is thrown with the same velocity at an angle alpha with the vertical. What is the ratio of the time of flight? What is the ratio of the time of flight? I'll give you 2 minutes to solve this. More the number of questions we do, remember, the better we are. And these are the type of questions that are going to come in the examination hall, my dear friends. And we intend to do all of those questions. Yes, my dear friends. Yes, do we have an answer for this one? Yes. Do we have an answer here? Option C, sir. That is correct, sir. Well done, Karthik. Well done, Shruti. So, how are we supposed to solve this? Well done. Time of flight T1 is 2u sine of alpha by g. This is the angle with the horizontal, my dear friends. T2, the second time of flight, is 2 times u sine of, now alpha is with the vertical. So with the horizontal, angle is 90 minus alpha by g. 90 minus alpha, sine of 90 minus alpha is cos alpha. You divide T1 by T2 and you end up with tan alpha. Do we all understand this? Yes or no? No or yes? Everyone understands this? Everyone got the answer for this one? The more we practice, the better we are going to perform in the examination hall. Please, 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 my dear friends, remember this. Please remember this. I hope you can remember this. Yes or no? No, yes. Can I now move on to the next question, my dear friends? Everyone is ready? Everyone is ready for the next one? Here comes the next one. Question number 4. Number 4. For a given angle of projection, so the angle of projection remains same, the horizontal range is doubled. What is the time of flight? And you shall have 1 minute, 2 minutes to solve this. Yes, my dear friends. For a given range of projection, what will happen to the time of flight if the range is doubled? Doubled. Yes. A, B, C, D. And I have an answer. Is that root 2 times, sir? That is correct, sir. How did you get the answer, Shaki? That is correct. That is absolutely correct. I shall give 1 more minute to the other students to catch up. Shruti, can you tell me how did you do it? Yes, Shruti, I'm waiting. Yes, you can unmute yourself and speak as well. Yes, dear. Yes, can you tell me how you have done this, beta? No one else got the answer for this one. Chandrika, Anjali, Kaushik, Kartik. Okay. So if I remember the formula for range is u square sine 2 theta by g. Here, what is given is for a given angle of projection. So this angle of projection remains constant. So sine of 2 theta also remains constant. G is constant. So I can write, my dear friends, that R is proportional to U square. Yes or no? For a given range, for a given angle of projection, range is proportional to U square. Can I have raised hands from everyone in the class that we understand this? Now let us talk about the time of flight. The formula for time of flight is 2u sine theta by g. For a given angle of projection, this is constant, g is also constant, 2 is constant. So I can say for a given angle of projection, time period, not time period, time of flight is proportional to u. Yes or no? No, yes. Now, if range is doubled, my dear friend, if range is doubled, my dear friend, then this implies what will happen to you? You will become root 2 times. Yes or no? No, yes. The new u dash will become root 2 times of original u. Yes or no? Range is doubled. If I have to double range, the initial velocity which I throw it should become root 2 times. Yes or no? Do we understand this? If we understand this, then time period, or not time period, time of flight is directly proportional to u. So my new time period t dash will become root 2 times of capital T. Everyone, if you have understood this, please raise your hand so that I can move ahead in life. Life has to move on. Shruti has understood this. Chandrika, Anjali, Kaushik, Karthik, where are we? Obviously, we are in the same universe, right? Have we understood this? Yes or no? How many of you got the answer? Please raise your hands. Lower all hands. I lower all hands. Karthik got the answer. Shruti got the answer. Chandrika also got the answer. Kaushik, what happened, bacha? Got the answer? Now, I will give you one question which is there from your own state ka CT. And this has come in JEE also many times, and this is the question, my dear friends, and I hope that you can give me a quick answer to this one. Remember, the more the number of questions we do, the better we are going to be, and it is a very high probability that the same question would appear in your attempt in JEE Main. Here is the question, and I am waiting for the answer. For a given velocity, remember its velocity is given, that means it remains constant. For a given velocity, a projectile has the same range for two angles of projection. I hope you understand what it means. If T1 and T2 are the times of flight in both the cases, which relation is correct? And you have 1 minute to solve this one, my dear friends. Then we'll move on to the next set of questions. The next set of questions. The next set of questions. Yes, my dear friends. What is the answer for this one? B is the answer I'm getting. T1, T2 is proportional to R. How many of you got the same answer, bacha? Range is same. Yes, my dear friends. Everyone got the same answer? Yes or no? No, yes. If everyone got the same answer, then that means there must be something good about this. Let us solve this. Remember, velocity is given as same and range is same for two angles. So I now know what those two angles would be. If one angle is theta, the other angle would be complementary. Theta 90 minus theta. Yes or no? No, yes. Raise hand will give me more confidence. So if I write the first time period T1, it will be 2u sine theta by g. If I write the second time period T2, it will be 2u cos theta by g. Now I simply got to multiply T1 into T2 will be equal to 2 by g taken common. And if I look in the sine theta, cos theta divided by g, this entire thing that is coming in the bracket is nothing but your range. Yes or no? No, yes. So you can remember this as an important point. T1 by T2 will be proportional to R square if the angles are complementary. Do we understand this? Yes or no? Yes. If the angles are complementary, T1 into T2 will be proportional to R. Yes or no? No, yes. And if you remember this question, question number 3, same question, complementary angles, we had seen that T1 by T2 is equal to tan alpha. That means if you can remember these two things for complementary angles, what you can remember for complementary angles, that if for the same velocity of projection, for complementary angles, T1 by T2 will be equal to tan alpha. At the same time, T1 multiplied by T2 will be equal to 2 by g multiplied by r. This is how you make shortcuts in life. And if you can remember these, both of these are valid only for complementary angles. You can save a lot of time, my dear friends, in the examination hall. Do we understand this? Yes or no? No, yes. Can I move on to the next question, my dear friends? Raise hands, thumbs will give me more answer, more satisfaction. Here comes the next one, question number 6. For a projectile, the ratio of maximum height reached to the square of flight time is g has to be taken as 10, my dear friends. I'll give you 2 minutes to solve this. Yes, my dear friends, do we have an answer? I'm waiting for someone to give me the answer. Five by four is the answer, correct answer, my dear friends. Yes, that is correct. Solution. So I know that H max is u square sine square theta by 2g, and time of flight is u sine theta, 2u sine theta by g. I have to square it. So I square it, and then I can find H max divided by t square. I hope you can do this. If I divide H max by t square, u square and u square will get cancelled out. Sine square theta and sine square theta will get cancelled out. And if you divide it correctly, what I think you will get is g by 8. Yes or no? No, yes. Will you get this g by 8 or not? 2 square becomes 4. 4 into 2 becomes 8. G goes in the numerator, g square by g. G get cancelled, g by 8. G is taken as 10. If you put the value of 10 as g, you will end up with 5 by 4. Do we understand this? Yes or no? No, yes. How many of you got this answer? Please raise your hands. Well done. Then this is, can you move on to the next question, please? Everyone has done this? Comes the next one. A cricketer, which of the following sets of factors will affect the horizontal distance covered by an athlete in a long jump event? Question number 7, I think, or 6. Doesn't matter. I put 7, so it is now 7. I'll give you 2 minutes to solve this. Yes, my dear friends. What is the answer for this one? What affects the long jump? Karthik has given me an answer, and the correct answer is it depends on the direction in which he leaps. Remember, when you talk about the horizontal distance that it covers, we are talking about range. And if you look at the formula of range, it is u square sine of 2 theta by g. So it depends on u, which is the initial speed. It depends on theta, which is the direction in which he jumps. So the correct answer is B. Do we all understand this? Yes or no? No, yes. Everyone understands this? Well done. Then I can move on to the next question. Yes or no? The more the questions we do, the better we are going to become. Yes or no? So here comes the last one, second last one probably in this category, and here it comes. A cricketer can throw a ball to a maximum horizontal distance of 10 meters. The speed with which he throws the ball is, you have to tell the answer up till the nearest integer. Yes, my dear friends, do we have an answer? Yes. Anyone with an answer? See, that is correct, Karthik. Well done. As soon as you see this maximum horizontal distance, it means maximum range, my dear friends. And remember the formula for maximum range. It is U square by G. Do we all understand this? Yes or no? No, yes. Maximum range is given as 100. You can take G as 10. So my U square becomes 1000 and my U becomes root over 1000, which is going to come approximately 31 point something something. So I can take it as 32 meter per second. Do we understand this? Yes or no? No, yes. Everyone understands this? Well done. Remember why we are doing so many problems here in this? Because these are all problems. Once you get a hang over it, you should be able to do them quite simply. Can I move on to the next question? Because these are the type of questions you are going to see in the examination hall. Can I move on to the next question, my dear friends? Yes or no? No, yes. Here comes the next question. Figure shows four parts of a kicked football. Ignoring the effects of air on the flight, so resistance of the air is neglected. Rank the path according to the initial horizontal velocity component highest first. So you have to tell me which path represents the maximum initial velocity. Highest initial velocity should be first, then after that, lower than that, then the lower one, and then the lowest one. So highest will be first, and lowest would be our last. And I'll give you 2 minutes to do this. Yes, my dear friends, do we have an option? Do we have an answer? Chandrika, Anjali, Kaushik, Karthik, Shruti. Yes, my dear friends, what can you understand looking at the figure, looking at the graph? We have an answer. Sir D. That is correct, my dear friends. It is G. Well done. It is definitely D. How did you get it? You have to look at the diagram, my dear friends. Now, looking at the diagram, what you see, all of them are having the same maximum height. Yes or no? All of them are having same maximum height. And maximum height, if you remember the formula H max, that will be equal to uy square by 2g. Yes or no? If they have the same maximum height, that means they have the same y component of velocity. If they have the same y component of velocity, their time of flight would also be same. Yes or no? No, yes. Do we understand this? Same maximum height means same y component of velocity. That means same maximum height. Now, if I look at range, the formula for range that I'm going to use is ux multiplied by t. If they have the same maximum height, they have the same time. If they have the same time, then I can say range is directly proportional to ux. The particle which has more ux will have more range. Vertical velocity is same. So whatever has more ux, it will have more u. Yes or no? No or yes. And therefore, 4 will be maximum and 1 would be minimum. 4 followed by 3, followed by 2, followed by 1. And that is the answer that we are looking at. Do we understand this? Yes or no? No, yes. Raise hands will give me more confidence that we understand this. Okay. Then you move on to this one. And then we will give you some notes of some questions which might not be so straightforward. And in the next class, we will wind up with more questions and the other types of projectile and something known as the equation of trajectory. So this is the next question. Four bodies P, Q, R, and S are projected with equal velocities. When I say equal velocity, they mean the magnitude is same. Because if equal velocity, that means angle of projection should also be same. So instead of this equal velocity, it must be equal speeds. So the magnitude of velocity is same, but having angle of projection as 15, 30, 45, and 60 with the horizontal respectively. The body which has the shortest range is which one? Which one will have the shortest range? 15 degree, 30 degree, 45 degree, 60 degree. I'll give you 2 minutes to think about this. I have an answer A, which is 60 degrees. Okay. What about the others? Option A, P, 60 degrees. Okay. Anyone with a different opinion? Or all of us are having the same opinion? Option A, Kaushik also says the same thing. It is quite simple, it seems. Yes or no? No, yes. Everyone got the answer? Option D. Shruti is getting option D. Yes. See, now we have difference of opinion. How are we going to solve this? This is no rocket science. We just use the formula. Range is equal to u square sine of 2 theta by g. Do we understand this? Now, u and g are constant. G is always constant. Now, u is constant for a given speed. So I can write now range is directly proportional to sine of 2 theta. Just put the value of theta and you will get the answer. If theta is 15, sine of 2 theta becomes 30. So range will be proportional to sine of 30. In second case, sine of 60. In third case, sine of 90. In fourth case, sine of 120. And you have the correct answer now. Which is more, sine 30 or sine 60 or sine for 90 or sine 60? Yes, my dear friends. Sine of 30 is the smallest and therefore P is your answer. Do we understand this? Yes or no? No, yes. Ray science will give me more confidence that we understand this. Okay, so these were the questions and we will be solving more of this in the next class tomorrow. But now let us move on to other type of question that could be asked. And the first type of question that could be asked apart from this is to find out the displacement of the particle, where the particle is as a function of time. So I can just show you and you can just note down how you can write the displacement of the particle as a function of time. These are not any magical things. We have just derived it. We have just derived it from the what? From the equations that we have. Yes or no? We understand this. So what has happened is, I just show you a diagram. I have thrown this particle from this point with an initial velocity of u and an angle of theta. After some time, the particle is here. The coordinates are x and y. Do we understand this? Yes or no? The x coordinate is x and the y coordinate is y. So if someone asks me what is the displacement of the particle or the position of the particle, it is simply equal to xi plus yj. Do we understand this? Yes or no? No, yes. This x will be equal to u cos theta multiplied by t, and this y will be equal to u sine theta multiplied by t minus half g t square. Do we understand this? Yes or no? You know, yes. Raise hands will give me more confidence that that we are on the same page. So I can write this r vector as, it will be a bigger thing. So u cos theta into t times I plus u sine theta into t minus half gt square times j. Do we understand this? Yes or no? If I have to find out the magnitude of this displacement, now it will be very long for me to write it. So I'll just write it in short. It will be root over x square plus y square. Do we understand this? That will give you the length of this vector, the length of this line, which will be the magnitude of displacement vector. Do we all understand this? Yes or no? No or yes? If someone asks you a very difficult question, what is the value of this tan phi, the angle that it makes with the origin? You can simply find it by dividing y by x. Your y is this, your x is this. Can I have raised hands from everyone that we understand this, my dear friends? Anyone understand this? I'll give you a minute to note it down. Please let me know once you have noted it down. Yes, have you noted this down? Then comes an important note. We have seen the angle tan theta. The tan of this alpha is y by x at the highest point, and this could come as a straightforward question. At the highest point, the value of this tan phi is half of tan theta. Can you remember this? Can you remember this, my dear friends? If you can remember this, you can easily derive this, but again, in the examination hall, you might not have enough time to derive it, and therefore if you can remember it, it would be a lot easier. Do we understand this? I'll give you a minute to note it down. Have you noted it down, my dear friends? Everyone has noted this down? Can I move ahead? Anyone is there in the class? Okay. Now we can also write the formula for velocity of the particle. Velocity at any point, and if I just draw the previous diagram, at any point, let me just put the previous diagram once again so that I don't have to draw it. At any point, what we have done in the previous diagram was we had found out the displacement. We had found out the value of x and y. But this particle also has a velocity that you can see v1. Yes or no? And it goes like this at an angle. It has an x component vx and it has a y component vy. Do we all see this, my dear friends? Raise hands will give me more confidence that we see this. Now, if I write this velocity v1, it will be equal to vx I hat plus vy j hat. Do we understand this? Yes or no? Now, this vx does not change. It remains same as ux. So, it will be equal to u cos theta. But this vy, because of acceleration in the downward direction, it will be uy plus at. If I put the value of uy, it will be u sine theta. Acceleration is minus g, so it becomes minus gt, where t is the time it takes to go from this point to this point p. Anyone understands this? Yes or no? This is the time it takes to go from O to P. Ding, 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 ding. Do we all understand this? Yes or no? No, yes. Now I can write this velocity v1 in the vector form, and it looks like this: u cos theta times I plus u sine theta minus gt times j. Do we understand this? Yes or no? If I want to find out the magnitude of this velocity, and it will become very cumbersome if I write the entire thing, I will just write it as root over vx square plus vy square. Do we understand this? Raise hands will give me more confidence that we understand this. Now they may also ask you in some very difficult question, what is the value of this alpha, this velocity, what angle it makes with the x-axis? Don't worry, you know this. Tan of this alpha is simply your vy component divided by vx component. The value of vy is already there. The value of vy is this. The value of vx, don't worry, is this. Do we understand this, everyone in the class? Yes or no? No, yes. I'll give you a minute to note it down. You can use the same diagram, just write the value of velocities. Don't have to draw a different diagram. You can use the same diagram. I could not use the same diagram because then I had to go back and my board was already full. Have you noted this down, bacha? Well, then I will end this class with a question that I want you to solve when you get back home and tell me the answer in the next class. A body is thrown at an angle 30 degrees to the horizontal with a velocity of 30 meter per second. That's the magnitude of velocity. After 1 second, What will be the velocity? It's a very simple question. We have already discussed it so many times, and I hope that you can solve it before coming to the class. In the next class, G has to be taken as 10, angle is 30, initial velocity is 30. You have to tell me the velocity after 1 second. Can you do this for me, my dear friends? Can you solve this question for me? Are you confident that you can do this for me? I hope you have noted this down. We will start our next class with this particular question, and before moving ahead, we will also solve some 3 or 4 questions from today's class so that this topic gets locked in your brain forever. And in the next class, we will try to wind up this motion in 2D because there is nothing more left apart from 2 different types of projectiles, one more type of projectile, and we will discuss that projectile and more questions and something known as equation of trajectory in the next class. So I'll see you in the next class. I hope you enjoyed this class. If you have any doubt, I'm always there to clear them out. Take care and have a very nice day, beta. May God bless you all. Bye, bacha.